how it's going to be set up. So here we go. Notes 3.6, which is called properties of logs. Okay, we could substitute the word properties and we're going to put rules of logs or tools, whatever, okay, of logs. So here we go. The first one, excuse me, so these are not in any order, they're just in random order. The first one is the log of A, so that means A, any base, any number, 2, 10, E, whatever, okay, of 1. These are not intuitive either. So this one's called the log of 1. So if you do the log of 1, the answer is always 0. Okay, so first rule. Examples of this would be log of 2 of 1. So like I said, any base, it doesn't matter what the base is. So if base is 2, it doesn't matter. The log of 1 is still, okay. Or for example, the log of this. So remember, no base is the base of 10, but again, it doesn't matter the base, it's still 0. ln, that one might be harder to see, but ln is just, again, that just means the log of e, right? So that's the same as that, so 0. Okay, it doesn't matter what the base is. Of 1, it's 0. Make sense? Okay, this is the next one. Again, in no order, just random order. This one is called same number and base. All these are very useful. Okay. So this one would say like this: if you have the log of any base, any whatever the base is, doesn't matter, and this happens to be the same, you know, they're both the same, the answer is always 1. Those of you that move on to have to take a math course in your future careers, not just architects and engineers, like nursing, you have to take college algebra and stuff. You'll use stuff like that again, in trig, calculus. So here we go. Examples of this would be log 2 of 2, same base, same number, 1. Okay. Where it's not so obvious is right here, right? Because it has no base, but the base is really 10. So 10, 10, right? They're both 10s, so 1. Another one where it's not so obvious, natural log of E. Okay, so you have to think about ln. Remember, ln means log of E. So you have EE, so that's why it's 1. Okay. Okay. Any questions thus far, guys? Hopefully it's bringing back, I mean, you have seen it in algebra 2, okay? Or you should have. So here we go. Next one, it's called the product rule. Product means multiplication. So, multiplication rule. So that one looks like this. If you have the log of any base, again, it's not dependent on the base, of m n. So mn is implied that you're multiplying m times n. Okay, that's what's called multiplication rule. So if that's the case, we can switch that for Anybody happen to remember what it becomes? No? Okay, no problem. I was just wondering. It becomes addition. M, N. All right, so multiplication, because you were multiplying right there. So multiplication turns to addition. Okay, one thing I want you to know is with these tools, sometimes we go from here to here. Sometimes we go backwards. Sometimes we take addition and we shrink it down to multiplication. So it works both ways. Okay, so I guess this would make better sense. You can go either direction. Okay. So this is the actual rule. Okay, let me show you what it's not. Let's do what it is versus what it's not. That's what's confusing the students at first. Like, when can you do it? When can you not do it? Okay, so let me show you the difference. Excuse me. Okay, so this is what it is. So for example, if I have the log of 3x, it's 3 times x. Right, so I can expand that to say the log of 3 plus the log of x. Right, that looks exactly like this, right? So m times n plus. That makes sense? Okay, here's what it's not. Okay, so you don't get it confused. I can't do, put this one in red, the log of 3 plus x and then turn it to the log of 3 times x. All right, I need to let that sink in so you can understand why that's not true. So notice it's called the argument. It's called what's inside the parentheses. So inside the parentheses you have the m times n. Outside you have the plus. Here they're putting the plus in the argument. That doesn't work like that. Okay, so you can't do that. This is false. Not true. Okay, that's not true. So just be careful. Notice, let that sink in the difference, right? You can do when it's multiplying, but you can't take the add and turn it into multiplying. Does that make sense, guys, what I'm saying? Okay. All right. So next rule, it's called a quotient. Quotient is a fancy word for division. Okay, so just like you have your multiplication rule, you have your division rule. Okay. So division rule looks like this. The log of any base, so again, the base doesn't matter, it can be any base, of m, or you should use colors here, m over n. Okay, so a fraction means divide. You're dividing the top by the bottom. And here you can use common sense. If multiplying turns to add, it would follow that division turns to subtract, and that's exactly what happens. Okay, so log of a, same base, log of a, m, and minus in the middle. Okay. So division can turn to subtraction. Or vice versa. Subtraction can shrink down to division. Okay, so this is the rule. Okay, let's do a little what is, what it's not. What could we say that instead of, Any ideas what we could say instead of what it is, what it's not, so we don't have to write that over and over? Maybe true, false. Yeah, we'll do that next. Okay, here's what it is. Log of 4 over 5. So that's the same as the log of 4 minus log of 5. So that's true. The only way you can mess that up is subtraction. The order does matter, right? So this goes first, this goes second. If you do those out of order, that would be wrong, because 4 minus 5 is not the same as 5 minus 4. With subtraction, order is very important. Okay. Here's what it's not. So you can't do, for example, the log of x minus 5 and then say that, oh, that's the same as it's not that. Okay. And it's for the same reason. So again, this is false. It's for the same reason of who goes in the parentheses, who doesn't go in the parentheses. So in the parentheses, it has to be divide. You can't put subtract in the parentheses. Does that make sense, guys? Or what else could you possibly think? Well, you could also think this maybe. Oh. Log of x or something like that. It's hard for me to try to think of all the ways you could think, but that's also not true. It only works when it's dividing, and you can turn it to subtracting. Or if you're subtracting like this, where it's not in the parentheses, then you could turn it into dividing. Okay, and we'll do examples, but I'm just trying to clarify for you. Okay, any questions so far? Okay, let's keep on going. So quotient rule, two more tools. Power rule. This one's really, they're all important, but I feel like this one pops up more frequent than the other. So maybe put a little star on this. We use this one a lot. Okay, power as in exponent. Not as in like power 4 or something. Okay, we're talking about the little power, the little number up there. So, excuse me, this one looks like this. Log of any base, any number. The important thing here is the power. Okay, so the little power. Anybody happen to remember this one? Somebody did last class, that's why I asked. I wonder. I bet some of you know, but you're not sure if you're right. It can drop to the front, and then it's not a power no more. It becomes something you're multiplying by in the front. Okay? So, or vice versa. If you have something in the front, you could put it back up as a power. So I don't have a true false on this one. I don't know how you could mess that one up, but I can show you examples. So, well, let's box this in. So examples of this would be, for example, log of x to the 5. So that's the same as if you bring the 5 down, so 5 log x. So I brought this down. So it brings down, becomes something that you multiply. Or you could go the other direction. You could do, for example, if I have 3 log of 2, 3 times log of 2, you could bring that 3 up as little power. So log 2 cubed. These tools work both ways, again, both directions. We're good, guys? Okay. Last rule for today. I say today because there's still another rule, but we'll do that one on a separate day. This one is called the equality rule. Kind of a weird name. Equality rule, but it's very powerful. So this one says this. The log of any base b, so any number there, okay, has to equal the log of any base of c. Okay, so this is so there's some conditions on this that they're not as obvious until you know what you're doing. Okay, so I don't know if you noticed, but notice the base is the same. Okay, so base, same base. So in order to do this, this has to be true. Same base. Okay. And then how many logs? Only 2 logs. So only 2 logs. So these are conditions for this to work. Okay. So same base, only with 2 logs, and 1 on each side. And the reason I can come up with this is because I know where students mess up, so I've known they messed up like that in the past. So what happens if this is true, so same base, 1 on each side, only 2 logs, they cancel. And then you're left just with B and C. So it gets completely rid of the logs, which is really convenient. Okay. Okay, so let me show you a true false. And this one I can. So true versus false. What it is, what it's not. Okay, examples of when you can do it, when you can't do it. So for example, we could do the log 2 of x plus 5 equal log 2 of x minus 1. So notice it meets all the conditions. Same base, 2 logs, 1 on each side. So the logs can cancel. And it turns this complex problem into algebra 1 problem after that. Okay. You just solve for x after that. Okay. Here's what it's not. So a lot of times students will see, oh, they all have the same base. So I remember that rule, that means they all cancel. It's not true, okay, that's false. You can't do that. Okay. You can't do that because you have 3, okay. Actually what we would do on this one is we can switch addition to multiplication, but we can't cancel them. Does that make sense, the difference? Okay, so anyways, that's all the rules, okay. So I'm going to separate the video. Now we're just going to do examples.